the last lesson I inject that. All right, this is it, the binomial theorem. Pascal's triangle, hi. Last lesson. It's 5 pages. We're going to need a little bit of focus to get through it. Pascal's triangle, we went. Has no bearing on the binomial theorem. I am not a better individual having known that.
I think that's
Okay. Okay.
that can be possible.
Okay. Can we just talk about Pascal's triangle? Okay, so in Pascal's triangle, we did this yesterday, we found the pattern. You can use Pascal's triangle to do the coefficients on binomial theorem. That's why Pascal's triangle is important. So if we were to do the next line of this, let's do the next line.
5. Well, 1.
So 1 on the outside.
10, 5, 1.
Right? Could you do the next line after it? Hopefully you could, right? You're adding the two numbers together of the above line to get your next number. Nice and easy. Pascal's triangle. He was super pumped. He did this in his spare time. This is the theorem that he found. You too in your spare time. So let's talk about the patterns in it. The first pattern we already talked about. It's the adding together. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. Right? You see the pattern there?
Yeah.
Find another pattern.
It goes 1, 2, 3, 4, 5, and the second diagonal column, so it's going to go on, it's going to keep going up.
So this one you anticipate to be 6.
Yeah.
Okay?
And then the next one's going up every heap. Like, oh, never mind, I screwed up. I had it right.
Okay. Something even more obvious. So we've got the
All the ones are on the outside.
ones on the outside. So the second diagonal is consecutive numbers. There was a question on the second provincial exam about Pascal's triangle specifically.
Every second number doubles.
Every second number
And
doubles.
it's like 1, 5 will be like, I guess the two ends of it are kind of the same. Like 1, 5 will be like, you know what I mean?
No. Consecutive numbers, 1 on both sides. And I'm just going to call it the adding pattern. Are you guys okay with that?
So that's like second diagonal and consecutive.
Yeah, second diagonal is our consecutive numbers. That's core English. We did the, so determine the sum for each horizontal row. Horizontal rows. Horizontal. What's the sum of the first row?
2.
Try again.
1.
Okay. So the sum of the first row is 1. The sum of the second row is 2. Sum of the third row?
4.
Sum of the fourth row? 8.
Yeah.
So you
Sum.
multiply that by
By 2 each time.
Sum of the, what are we on, fifth row? Are you sure?
Yes.
So we would anticipate this would be
32.
32. Now it's a pattern. It's doubling every time. Linked to exponents. You like that? Got that? Connected? Each number of Pascal's triangle can be written as a combination using the notation NCR, where N is the number of objects, R is the number of selected objects. For example, you can express the third row as, so remember when it has a 0, or N and R are the same, what's the value?
1.
1. Okay? So we know that this would be 1, this would be 1, and this would be 2. So this is the link from Pascal's triangle to the binomial theorem. In the binomial theorem, when we're doing an expansion, you know how when you have that's 2 of 5. What would you guys do? Okay, I'm gonna take the phone. I'm gonna throw it out the window. It's our last lesson. Enjoy it.
You would apply that to both terms.
No, that breaks my heart. I would have to expand it, right? It would be 2x plus 4 times 2x plus 4 times 2x plus 4 times 2x plus 4 times 2x plus 4, right? You would expand it. And you guys have all the time in the world, you'd love to multiply all those out and figure out what it all equals. I'm sure you would. The binomial theorem is going to help us find that solution faster using combinations. So that's why it's included in chapter 11. Question on the provincial exam was, how does Pascal's triangle relate to the binomial theorem? That was on lesson exam number 2, I think, of the new curriculum. Express the fifth row using combination notation. Fifth row. First of all, let's talk about how many terms are in the fifth row. We've done the fifth row. So that's row 1, row 2, row 3, row 4, row 5. How many terms are in there?
5.
1, 2, 3, 4,
5.
5. In the sixth row?
6 terms.
1, 2, 3, 4, 5, 6. That's exciting, isn't it? Yeah? So, express the fifth row using combinations. Wow, this is fun.
So, what are we expressing? The terms?
5, 0, 5. And we know it has to go to 5, right? 5, 2, 5, because it has to be 1 here and 1 here. So I want you to count how many terms you have there. 1, 2, 3, 4, 5, 6. We have a problem because how many terms are in the actual fifth row? 5. But if we do it this way, we're going to get 6. But we know we have to have 0, 5, choose 0 here, and we know we have to have 5, choose 5 here, right? Yes. Because we need 1s on either end. So here's the deal. When you're counting and you include 0 in it, that's a new digit. So when you start counting on your fingers, do you count 0? No, you count 1, right? So now I'm asking you to add 0 as a digit. So this is 1. This is 0. 1, 2, 3, 4. So what can my end value be? 4. This is 0. When you count on your fingers, do you start with 0? No, you don't, right? You always count it as 1. But in binomial theorem, we have to include the 0 there because we need the value of 1. So, when you're doing your end, you take your row number, and whatever your row number is, so if you're looking at the 20th row, and you have to subtract 1 from it because now we're including the digit 0. Does that make sense to everybody? So instead of doing it this way, and I knew that would be a mistake that would happen, so you probably wouldn't think of it. So the row number minus 1, so n is 4. So now when we do this, it's going to be 4 choose 0, 4 choose 1, 4 choose 2, oops, 4 choose 3, and 4 choose 4. I know that this has a value of 1, I know this has a value of 1, and I have 1, 2, 3, 4, 5 terms. This is imperative that you remember this.
So whatever row it asks you, just go to the row before.
No, you don't go to the row before you use your n is one less than whatever your row number is, okay? Is everybody okay with that? Yeah? Okay, here we go. We're gonna multiply some stuff. Anything to the exponent 0 is what? 1. So that's nice and easy. Anything to the exponent 1 is? Itself. Even easier. Okay? What's this one?
Square. So x
X
squared plus x plus y plus.
Ooh, plus one. That would have been a disaster. This one?
So
X.
So really what we're doing is we're expanding this. So we're taking this and multiplying it by that, right?
It's gonna be x cubed
plus
2xy squared and y cubed.
No, you missed one. You missed one.
2.
So really this is like saying x plus y times x plus y times x plus y.
Don't you just have the one up there by it?
Exactly, we're taking this and timesing this, right? So if I do that, x plus y times x squared plus 2xy plus y squared. Okay, I am officially running out of room, so you're just gonna have to bear with me here. So x times x squared is x cubed, which you were right. X times 2xy,
2x squared.
2x squared y.
Oh.
X times y squared, this is the one that you missed, plus xy squared. Guys, this is the lesson, so if we're not 100% sure how to do this, it's going to be a little bit of a disaster. So this is going to be y, so x squared y, plus 2x squared plus y cubed. So now I gotta combine like terms. Yeah, I see you're all super excited to combine like terms. Are there any like terms?
Yeah. The x squared.
These ones, right?
And the x plus one.
And these ones. So, I'm gonna have, let me just move up. I'm gonna put it up top. Is everybody okay with that? X cubed plus 3x squared y plus 3xy squared plus y cubed. Everybody okay with that? Yes. Now this is only works for binomial theorem, so only two terms. Okay, so what I want to do is I want to go back and look at coefficients. So that's 1, that's pretty easy. What are the coefficients on x and y?
1.
1 and 1. What are the coefficients here?
1.
1.
2. 1.
Talk about the coefficients here.
1. 3.
Okay, flip back to page 1, look at your triangle. The first set of your Pascal's triangle, right? So using combinations will help you figure out not what these are, not what the variable exponents are. They will figure out what your coefficients are. Okay, so the link to Pascal's triangle and the binomial theorem is we're using the pattern from Pascal's triangle to help us determine the coefficients of the terms in binomial expansion. Of course, you all wrote that down, you'd be able to answer that question, no problem on the into exam. They arrived today.
Did it go over them? Cut it over?
Absolutely not, I don't get to see them.
What happened?
They're locked away.
Where
I don't get to see them.
What if we did that?
We did one.
Well, you just keep
I lose my job.
What if we didn't tell anybody, they don't found out?
Yeah, okay, I love you all, and you guys are.
What if you break into the school of an
Perfect, go ahead.
I'm just happy about that.
So that's a criminal record,
True that.
and you're probably gonna be a court date or something on the day of the exam. So-
Why tell them we never thought of it? Suddenly,
If we just gonna let them do it? Okay, all right.
would have benefited all of us.
Okay, patterns above. Number of terms is always. Okay, number of terms. So what's my power?
0.
0, how many terms do I have?
1.
Power of 1, how many terms do I have?
2.
Power of 2, how many terms do I have? 3. 3, exponent of 3, so I'm going to have 4 terms. Does that make sense to everybody? So the number of terms is always what?
One more than power.
N plus 1. N plus 1. So if your exponent n is 15, how many terms should you have? 16. The first term is, I'm trying to put variables here. The first term is what? The first variable to the entire power. And the last term is the second variable to the entire power. So this is to the power of 3. My first term is x cubed. My last term is y cubed. Make sense? So if I had a and b in there, it would be... Okay. The exponent on the first term begins with the same value as...
1.
the same value as the exponent. I need to make these lines bigger. And what happens? So what happens to x squared, or what happens to x cubed? Where does it go next?
X squared.
And
No, that's correct.
to the single power, to the power of 1. So what's happening? 3, 2, 1. What's the x in here? 0. So what happens? They decrease. They decrease by 1. The exponent of the second term, where does it appear? Where's the first time we see y? Where's the first time we see y? What term do we see y? We see it on the second term. This hard stuff. And what happens? It increases by 1. Okay, the sum of the exponents in each term always equals
The same as the
the same as the binomial, so the exponent of the binomial. So at any point when you look at this, what's the exponent on the y? 1. So 2 plus 1 is 3. 1 plus 2 is 3. This one's 3. Always in each term, the exponents will add up to the exponent of the binomial. Make sense? These are always to check your answers, so I'm sure you're all super excited. Oh, you're never gonna get this. Coefficient combinations. Are symmetric. They read the same left to right. Hey, do you guys know what that's called when a number reads the same left to right? No?
What do you mean?
And right to left? It's a palindrome.
I knew it for its word, so.
Same as numbers. Yeah. There you go. There's a little fun fact for today. Okay, the coefficient combinations are symmetric. They read the same left to right and are blank using n as the value of the power. Can't remember what I put in that blank.
Did you just leave it blank on your paper, or you usually have
My paper, I don't have anything. I can't remember. We'll come back to it. We got to get through 3 more pages. Okay, here's the thing. the coefficients, the coefficient combinations, that applies only, it applies, let me see this easily. This is nice and easy, because what are the coefficients in the binomial? They're one on both, right? Nice and easy. So I know the combination of the coefficients will be Pascal's triangle. We just discovered that, right? Here, things get a lot more complicated when we do this. Remember the pattern of graphing a quadratic? 1 away, 1 times a up, 1 squared times a up, right? If there was a coefficient, you guys remember that? The pattern's really simple when I have the graph y equals x squared. Because I go to the vertex and then I go 1 away on each side, 1 squared up, 2 away on each side, 2 squared up. We have to multiply it by the a coefficient. We're going to do that same principle here, right? So, yes, it's still the coefficients are there, but we're going to have to do some multiplying because the binomial now has coefficients. All right. For this, the binomial expansion here, the coefficients are what? You can even give it to me in combination form. Okay, how many terms should be in this? In 7. Okay, we were talking rows on the triangle last time, right? Rows on the triangle because we're counting in 0. When we have, and we talked about this before, on page 2, when we have an exponent of 6, we should always have one more term, right? We did that, counted them, go back to page 2. If I have an exponent of 2, I'm going to have 3 terms.
Yes.
So if I have an exponent of 6,
You're gonna have 7 terms.
I'm going to have 7 terms. So my n for this is going to be 6. So if you're counting off the triangles, it's 1 less. If you're dealing just with exponents, n is the exponent. So the coefficients would be 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, let's see, and 6 choose 6. What are those? Number-wise, what are they? Oh, look, I'll do the ones for you here. Got those. What would this would be 6. And what do we know about, it's like a parabola, what do we know about it? It's symmetrical, so what do we know this one will be? 6. Don't do more work than you have to. Okay? So this is going to be how much? 15. So if this is 15, this is 15, 6 choose 3, 20. So you've just done the coefficients for every term. They haven't calculated every term, we haven't done those, but those are the coefficients. It's way easier than actually multiplying it out, eh? Yes? With patterns, you can do this way faster. Okay, so I'm going to tell you that this binomial theorem is going to ask you to do 2 things. It's going to ask you to expand, so you're going to show me all the terms, or it's going to ask you to find the 15th term in a binomial expansion. Those are the 2 things it's going to ask you to do. So we're going to expand this first. So it wants the first 3 terms. Model 8, it wants the first 3. And there's no coefficients on it, so it's nice and easy. So let's talk about it. What's the coefficient of the first term?
1.
Okay, let's put it in combination so we keep the pattern going.
1.
No.
6.
Put it in a combination
8
form.
choose 0.
Yes. So 8 choose 0, because that's our first term, right?
Yeah.
Okay, so let's talk about the pattern of the variables now. So first term shows up, and it is alone, and it is to the full exponent. When does that second term show up? Nope. When do we first see the second term, right? So now, what's my coefficient? 8 choose 1, right? Goes in order. What happens to the first exponent? It goes down by 1, yeah, so it's 7. And then my second variable shows up for the very first time. It has to be to the exponent 1, because what do these have to equal? 8. You get the pattern? Much easier to do than actually multiplying this whole thing up. Now we do the third term. It only asks us to do 3, so we're going to do 3. So we're going to have 8 choose 2. My x is going to go down to
6.
and my y is going to increase to 2. 6 plus 2 is still 8. So now we're just going to calculate the coefficient. So what's 8 choose 0? 1. So I get x to the exponent 8. What's 8 choose 1? What's 8 choose 1? 8. So 8, x to the exponent 7, y, plus 8 choose 2. Eight choose 2.
Is that the third term multiplied by x exponent 8?
What?
Is x exponent 8 being multiplied by 8 or 8 c2? Never mind.
What does this equal?
8.
No, it does not. What do each row of Pascal's triangle start with?
1.
So it is multiplied by 1, but I didn't feel it necessary. Anybody?
Just stretching.
Oh, here I am thinking you're doing the math. 8 choose 2, 28. So 28, x to the exponent 6, y squared. Super easy to let me do all the math for you, but I know that we're to that point in the year, but it's a little bit handy to try it yourself. Okay. Okay, we're going to expand the first 4 terms, but now we have a subtract sign. This is the first time you're dealing with that negative. Are you ready to rock and roll? Think you can handle it? So, what is my combination? 14 choose 0. X to the exponent? 14. So, I'm going to put plus, no y on this one. So now I've got 14, choose 1, and that's going to be x to the exponent 13. Now, here's the dealio, ladies and gentlemen. We have a subtract sign. So that's a negative y. That's like saying x plus negative y. Everybody okay with that?
No.
Perfect. So negative y, and what's negative y? To the exponent 1. The next term is going to be 14, choose 2, x to the exponent 12, y, negative y to the exponent 2. Great. Got the pattern here? Plus 14 choose 3, x to the exponent 11, negative y, negative y to the exponent 3. So we got to look at what this does to our adding. So what's 14 choose 0? 1. So 1 x to the exponent 14. What's 14 choose 1? 14. So 14, x to to the exponent 13, negative y to the exponent 1. That's just negative y. So what I'm going to do is, these are all multiplied together, so I'm going to transfer that negative through to here. So now they're not added together, they are subtracted.
Is that one halfway on the edge?
No, it does not, sorry. Serge just asked me last time, I didn't put it in, so I put it in now. So now, I know that y squared, what's going to happen to that negative? It's going to be positive, right? So 14 choose 2. 91, thank you. I have x to the exponent 12, y to the exponent 2.
So wait, that negative y was in?
Because what?
Oh,
Because it's squared, right? So 14 choose 3. 364, thank you. 11, and this is a negative y. And negative y cubed is what?
negative.
So that means that changes to a subtract sign. Okay, I'm gonna hit pause. You guys are gonna try this one on your own. Oh, no, that has a coefficient, never mind. No, we'll do it together, we'll do it together.
Good decisions.
Good decision, yes? Okay, so it says expand this. It doesn't say expand in the second term, it doesn't say expand in the first term, it just says expand, that means you're doing all of it. It's only the 3, so we should be okay. All right, so what is my first combination? 3 choose 0. Okay, now what is my first term? 2x. So it's 2x to the exponent 3. Notice my 2x is in brackets because you have to cube that whole first term, including the coefficient. My next one is going to be 3 choose 1. My first term is now going to be squared. My second term is going to be to the exponent 1. My next coefficient is 3 choose 3. Yeah.
Have you marked that?
No, we haven't finished yet. Yeah, tell me about it. It's emotionally exhausting, eh? And I've run out of room, so I'm just going to put it down here. My last term is going to be 3 choose 3. What's going to happen to my first term? There was 1 here, so where's it going to? 0, because we're going down, and this will go 3. Okay, so now we're going to evaluate it. 3 choose 0? 1. That's right, everybody. Don't show it all at once. Okay, so here's the thing that screws people up. Don't forget to cube your 2. So what's 2 cubed? 8. So this is going to be 8x cubed. So there's my Pascal's triangle coefficient, and 2 gets cubed, so that gets brought down to here. Now this term, 3 choose 1, hopefully is 3. Now what am I doing? I'm squaring the 2. So this is going to be 4x times b. My next, I really should have started the line down. What? You're right, it should be, sorry. I got so excited to square the coefficient, I totally forgot about the variable. 3 choose 2.
Only 1.
Becomes 1. 3 times 1.
No.
B.
Oh, 3 times 2x times b squared. And then this one here, 3 choose 3 is 1. 2x to the exponent 0.
Oh,
1. And then I've got b cubed. So when we put this all together, I have 8x cubed, 8x cubed plus 12x squared b plus 6x b squared plus d cubed. This is my answer. If I have an exponent of 3, how many terms should I have? 4. 1, 2, 3, 4. What should my exponents all add up to? 3. 3, 3, 3, and 3. Okay, so I know I'm on mostly the right track. Okay, so this is what you're going to see on the formula sheet. It looks ugly, but it's exactly what we just did. You ready? No. No?
It doesn't seem like it.
Okay. Okay. So this is what you're going to see on your formula sheet. Looks ugly. It means exactly what we've just been going over. So if you're trying to find the 7th term, your k value is going to be 6. So this, you're going to be asked to do 2 things. You're going to be asked to solve for a specific term in a binomial expansion, or you're going to be asked to expand the whole thing. Those are the 2 things they're going to ask you to do. And James, you need to know how to do both. So what we did is we just did the expanding of the whole thing. Now we're going to be plucking a term out. Okay? This is for finding a term. Finding a term, you're going to use this setup here. Not terrible. So if you're trying to find the 7th term, your k value will be 6. Why is that? Because we start counting with what? 0. Counting with 0 now. So we're finding the 4th term of this binomial expansion. We are not going to waste our time expanding the first 7 terms. We're going to go right to the 7th term. You understand what I'm asking? The difference between what we just did? Okay, so find the 4th term of this. So I know that, what's my n? My n is my
7.
exponent. So I know that n is 7. And I know that k is finding the 4th term. So it's
4. No, 3. 3.
1 less, because we start counting with 0. 0, 1, 2, 3. How many fingers am I holding up? So I'm looking for the 4th term. So k is 3. Okay, so now we're going to fill in the formula. So our combination is going to be 7 choose 3. That's our combination, our numerical coefficient, our link to our Pascal's triangle. Our first term is 2x, and it's going to be n minus k, so 7 minus 3. And then our second term, which is negative y cubed, is going to be to the exponent k, and k is 3. All right, so 7 choose, well, let's do this, so we'll leave that right now. 7 choose 3, so it's going to be 2x to the exponent 4, and negative y cubed to the exponent 3. Everybody okay with that? Yes? Nothing magical, I did a subtraction.
Is that just one term, the whole thing?
Yes, because what are we doing? We're multiplying all of these. So terms are separated by add or subtract signs. Okay, so now we're going to do 7 choose 3. Actually would love you guys all to try it as you sit here and wait for someone, one of your colleagues, to sit here and do the work for you. How much? 35. Okay, so again, I have to, this is a really easy mistake to make, and it's going to screw up your entire answer. I've got to put 2 to the exponent 4, so that is 16x to the exponent 4, and this is going to be negative y to the exponent 9. Now, all I'm gonna do is multiply the coefficients together. 35 times 16 times -1. So what is this? It's gonna be a negative answer, right? 560, x to the exponent 4, y to the exponent 9. Nope. Yes. Yes, that's good. So here's the thing, you go, but 4 plus 9 isn't 7. It isn't, right? The ones that we're looking for are here and here. What's 4 plus 3? 7. We had to apply it to the terms which had exponents on it already. So this is my fourth term. Okay, I'm gonna hit pause. You're gonna try this on your own. Okay. I know that, ladies and gentlemen, it's hard to share a calculator. It's like you're a whole class of only children all vying for one calculator. So I find this useful to write this down here. So I've got 15 to 6, nice and easy. 3a to the 15 minus 6, and negative b squared to the 6, to the exponent of 6. So if I do this, 15 to 6, 5,005. If I do this, I gotta do 3 to the exponent 11. No, 3 to the exponent 9. So 3 to the exponent 9 is 19,683, a to the exponent 9. Now, when I take -1 to the exponent 6, am I getting an odd or even?
Positive. Oh, wait.
Positive, because it's an even exponent. So this is going to be b to the exponent 12. So if I multiply those all through, I'm going to get 98,513,415, a to the exponent 9, b to the exponent 12. And you all got that, right? What's 15 minus 6?
9.
What's 3 to the exponent 9? So this is not unheard of that you'll see one of these fraction forms. Not unheard of. 10-minute break. No, we need to get through this. I wish. Find a term that contains x to the exponent 15 in this. That's a very valid question. Got to check the pattern of exponents. So you're going to have to do some quick things. So we know that my first term is going to be C10, choose 0, right? And then I'll have x to the exponent 3, the exponent 10, and then the next one, -2 over x squared to the exponent 0. That's my first one, right? I don't even need to write this, because we know that that's equal to 1. So I'm not really concerned about evaluating this, but I know you all can. So what is the exponent here? So it's going to be x to the exponent 30, because one exponent's inside, one exponent's outside, and you multiply. So my second term will be 10 choose 1. So this is going to be x cubed to the exponent 9. This one will be -2x squared to the exponent 1. So this, I'm not worried about evaluating this, but you know it's 10. I'm only worried about finding out which term has x to the exponent of 15 in it. So if I do this, 3 times 9 is 27. So I'm going to have x to the exponent of 27 multiplied by negative 2x squared. So if I do the math on this, I'm not even really concerned with the coefficient. I'm not looking to find the term. My second term is going to have x to the exponent of 25 in it. Because when you're dividing and they have the same base, what do? Subtract the exponent. So if I do my third term, just to double check, because I know that it seems to be going down by 5s, I'm going to do my third term just to double check. That's going to be x to the exponent of 3 to the 8, and this will be negative 2 over x squared. So 24 minus 4 is 20, so this, in the third term, it'll be x to the exponent of 20. So the pattern that I notice what's happening, I'm going down by 5. So what term will have x to the exponent of 15 in it? The fourth term. So now, I know that I'm looking for my fourth term. Finding the pattern is the only way you can predict where x to the exponent of 15 will be. There is no fast way of doing that. You have to find the pattern. It's kind of like the remainder theorem. You have to do a couple of calculations first in order to get to the actual question. So the fourth term, so n is going to be 10, r is going to be, okay, sorry, not r, k is going to be 3, one less, because we start with 0. So now 10 choose 3, x to the exponent of 3, 10 minus 3, and negative 2 over x squared to the exponent 3. So 10 choose 3 is 120.
Is that?
X to the exponent 21. And I'm going to have to do some math here. Negative 2 cubed, negative 8. X squared cubed is 6. Everybody okay with the math that I did at this point? I got some nodding heads. I've got some people doing something else. So this is like saying negative 8 times 120 is going to be negative 960. And then I've got x to the exponent 21 divided by x to the exponent 6. So negative 960 to the exponent 15. Okay, I don't think we need to do the next one as practice. We're running out of time. I can tell you what the answer is.
Yeah.
Yeah? No, sorry, that's the answer for that one.